So in number 1, you should have said that the integral represents the height, or I should say the change in height of the cone in feet in the first 5 hours. In the first 5 hours. Okay, so again, that h of t, you don't know what it looks like. It could look like here's t and here's 5 hours. Okay, it could look something like this. All right, where you integrate from 0 to 5, and this is in feet per hour, so feet per hour, and the integral from 0 to 5 would be all the net area, okay, and that h of t represents the rate at which the height of the cone is changing, and the total change would be the area above minus the area below, and that is the change in height in feet in the first 5 hours. Okay, so we can talk about these in class, but that's the interpretation, and as we do more examples, you'll see that. So I'm just going to go ahead and finish up what these mean. Number 2, the integral represents the change in the position of the particle in feet. So the change in position of the particle in feet, okay, from time t equals 3 seconds to time t equals 10 seconds. Alright, and then number 3, the integral represents the change in the number of bacteria, change in the number of bacteria, try to write neater, in the dish okay, from time t equals 2 hours to time t equals 6 hours. Okay, I don't see my next worksheet. Where is my next one? Alright, that's wonderful. It must be under here. Let's see. Alright, what'd you guys do with it? It's not there, it's not there. I don't have the ability to pause. I did find it. Thank you for being patient. Okay. Now here's where it really gets fun. Here's number 4. The velocity of a particle moving along the x-axis time t. So the position x of t is 5 at time t equals 2. So if you remember, we have position and then velocity and then acceleration, but we're not talking about the acceleration right now. So the integral expression that represents the position of the particle time t equals 10. So here's the thing. We've got t equals 10 and we've got t equals 2. This t equals 2 is our initial position. Because keep in mind, we're talking about a particle moving along the x-axis, so we have to have an initial position at time t, and that in this case, our initial time would be t equals 2. You can start the time at any time you want, but if you have an initial time of t equals 2, then that initial time is going to be the lower limit of integration. Okay, the time that we don't know of, don't know where the position is that time t equals 10. So the unknown time would be the upper limit of integration, and v of t is the rate of change. So that's the velocity, rate of change, and that would be equal to, remember in the first video we said any antiderivative of v of t, that's x. Okay, well that's at x at 10 minus x at 2. Well, we were already told that x of 2 is 5, remember? So at time t equals 2, the position is 5. So we can replace this x of 2 with a 5. And so sometimes well, I mean, this is the integral expression, so you don't have any way of evaluating this definite integral, but that's not what it asked. It said, write an integral expression that represents the position of the particle at time t equals 10. Okay, well, at time t equals 10, that's the position right there. That's what we want. Okay, well, x of 10 then, if we just add 5 to both sides, then it would be 5. So therefore, let's put that over here. So therefore, x of 10 would be equal to 5 plus the integral. And remember, the integral from 2 to 10, I should say, the integral from 2 to 10 of the velocity represents the total change in position. So this guy right here, again, is the change in position, the net change in position. And the net change in position, when you add that, or it may be a negative, but if you add that number to 5, you're going to get the current, or the position of the particle at that time. So x of 10 represents the position of the particle at time t equals 10. Okay, so then that's part A though. Okay, so that's part A. Part B, it says write an integral expression that gives the total distance traveled. Okay, so we haven't talked about that, and I forgot to actually mention that in this example here. So let's bring it back to this example real quick. And this example says that the that's not the one I wanted to that's not the one I wanted to show you. Sorry, I was experimenting with that. If I can find it real quick. Yeah, this is the one. So this is the one we were working on, the total change in position. But what I didn't say was the total distance traveled would be the 9 plus the 3. Okay, so total distance, so you went, like, in other words, it went 9 feet to the right and went 3 feet to the left, but the distance traveled is 9 plus 3. Okay, so that's 12, obviously, but well, how does that pertain to this? Well, how do you find total distance? Well, maybe you guys figured this out already, and that'd be great if you did. Because we have talked a little bit about it, but total distance traveled would be the integral from 2 to 10 of the absolute value of v of t dt. So when you integrate the absolute value of v of t, then you have found the total distance traveled. Okay, can't tell you how often that happens. It happens a lot. You see that stuff a lot. Okay, and finally, P of t is the rate of growth of a rabbit population measured in rabbits per year. So if you were looking at graphing that, you'd have rabbits per year, and P of t is the rate of growth. So that's a rate per time measured in rabbits per year. And there were 100 rabbits in the year 2005. So at t equals 0, we know we're going to have a 0 there. At so p, let's just let x be the antiderivative. Okay, x at 0 is 100. So there were 100 rabbits at the beginning, and then in the year 2007. So if t equals 0 is the year 2005. So that's 2005. Then t equals 1 would be 2006, and t equals 2 would be 2007. Okay, so we want the integral from 0 to 2 of p of t dt, and I mean, you could think of that as x of 2 minus x at 0, but as we said, that x of 0 is 100, so you could replace x of 0 with 100. Okay, and add 100 to both sides. Add 100. Okay, and if you add 100 to both sides, then on the right-hand side we're left with x of 2. And that x of 2 would represent the rabbit population in the year 2007. Because you take the initial population and you add to that the rate, or the population change from t equals 0 to t equals 2 years of the rate of change, the rate of growth of the rabbit population. So this guy right here represents the total change in the rabbit population, and the total change in the first 2 years plus the initial population would be your answer. So the answer is 100 plus the integral from 0 to 2 of p of t dt. Okay? There you go. That's it. I'm going to end this video and we're going to pick it up in the next one. Pick up the, I don't remember that, I think it's worksheet 4 or 5 in the next video.